Alright guys, we are going to look at two more of those shortcuts today. So side, 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 and side, angle, side. Very similar to the congruence theorems that we learned about. This time we're looking at the similarity theorems. So for our first theorem, we have the side, side, side similarity theorem. It says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So all we know is that all of the sides have that same ratio, the same scale factor, and we can say that the two triangles are similar to each other. So we're looking at an example here that we want to know if triangle DEF is similar to ABC, and if triangle GHJ is similar to triangle ABC. So let's match up pieces here. So I'm going to start with ABC and DEF. So if you're not sure what order they go in, what I look at here is the shortest side in the first triangle is AB. The shortest triangle on the triangle DEF, or the shortest side on triangle DEF is DE. So I have 8 over 4, which is 2 over 1. Let's try that with another side. So BC is the middle side, and so EF is the middle side. So BC is 9, EF is 6. So 9 over 6 is 3 over 2. Those aren't the same, so already right away I can tell you these are not similar. We don't even have to go any further. If those don't match, we can be done. Now, if you're not sure, if maybe you didn't do the math right, you may want to go ahead and check that third side just to see, and then find your oddball one and check it again to make sure you actually did it right. Okay, now we're sticking with triangle ABC for this next one, but now we're going to compare it to triangle GHJ. So I'm going to use that same strategy. So I'm going to say AB is the shortest side, and then it looks like GH is the shortest side on this one. So I have 8 over 16. Those both divide by 8, so 1 over 2. Then BC is the middle value side, and it looks like HJ is the middle value. So BC is 9, HJ is 18. So far so good because those both divide by 9 and would give you 1 over 2. So then the last one, the last side we have is AC, and that pairs up with GJ. So I have 12 over 24, and again that will reduce, so 1 over 2. So then we can say that yes, they're similar by side, side, side similarity. And if we needed to write a similarity statement, we could say triangle ABC is similar to triangle, and we need to make sure that we're going in the same order. So AB was the short side, GH is the short side here, and then J. So is similar to triangle GHJ. All right, find the value of x that makes triangle ABC similar to triangle DEF. Okay, there's an easier way to do this and there's a more difficult way to do this. What I would look for the easier method is you're matching sides that don't have an x value. So I can see that BC and EF match up, and it's 4 over 10. That's way easier than dealing with an expression. So 4 over 10, if you want to, you can reduce to 2 over 5. And we'll set that up as the left-hand side ratio. So now I'm going small triangle to big triangle, left to right. So now it doesn't matter which side I pick. I think I'll go with AB here, just because it's shorter side, smaller numbers. So x minus 3 then would go on the top because it's the left-hand triangle, and then 20 would go on the bottom. So now I'm going to cross multiply. And so I have 5, and you want to really be careful because this x minus 3 is inside those invisible parentheses when it's on top of the fraction bar. And then we have 2 times 20, which is 40. So we need to distribute, so we get 5x minus 15 when we multiply it to each one of those equals 40. So I'm going to add 15 to both sides. So then 5x equals 55. Divide by 5. So I get x equals 11. And that's all it asks you to do is find the value of x. So we're done after that. Okay. So that's one of our theorems. Our other theorem is our side-angle-side similarity theorem. And it says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Now, we can't put tick marks on here because they're not the same. But again, what you're looking for, just like when we talk congruency, is that that angle is between the two proportional sides. That's why it's side, angle, side. So, looking at this picture, if you are drawing a bird feeder, can you construct the top so it's similar to the bottom? So basically, are those two triangles similar? So what I see right away is that we have one angle pair that matches up, and that angle pair happens to be between two sides. So what we want to check then is that these ratios are the same. So AB would pair up with DE, and CB would pair up with FE. That would be a statement of proportionality. And if we look, both of them have a ratio of 32/20. So without even reducing, we know that they're going to be the same. But we can reduce that. 32/20, both divide by 4, and we get 8/5. So both of them have that scale factor of 8 to 5. And then I also see that angle B is congruent to angle E. So we can say that, yes, triangle ABC is similar to triangle DEF. And if it asks, we could say by side, angle, side, similarity. Okay, so triangle similarity postulates and theorems. Again, we have talked about all of these. This is just a great place. You may want to circle this, highlight it. This puts all of them in one spot for you. So angle, angle, side, 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 and side, angle, side are the 3 similarity theorems. And it tells you the pieces of things that you have to know to be able to say these 2 triangles are congruent. So you'll see things like this where it says, tell what method you would use to show that the triangles are similar. So if you look, we have vertical angles right there, and so that looks to me that if those are proportional sides, we have the angle between the 2 sides, so it would be side, angle, side, similarity theorem. All right, guys, we are finished up with today. If you have any questions, please come in and see me. I will see you in class.